What is up, car and tech fans? Welcome back to another garage tinkering video. Today, as you've probably seen in the title, we're going to be launching into how to get the most out of LVGL, and more specifically, how we can get the most frames per second so we can ensure that whatever we've got going on our screen looks smooth and not all janky and jumpy. This is something we talk about a lot in my Discord. If you wanted to join that conversation, the link for the Discord channel is down in the description. But often people are coming across this problem where, things are going on the screen, data's coming in, they're wanting to display gauges and getting like 4, 5, 6 frames a second doesn't look great. And there are definitely some tricks we can apply in order to help solve that problem. So let's take a look at a typical setup that you might have, and then we'll see how we can improve it. This is the setup that we're going to be looking at. You've probably seen these a lot in my previous videos, but this is a 2.1 inch ST7701 LCD screen. It's being driven by this WaveShare 2.1 inch touchscreen. It's a little bit too big for my needs, so currently it's just driving this screen. And we have a simulated canvas here, which is sending the data that this screen is displayed via ESP now. So it's just broadcasting that over, and it's doing it currently at 10 Hertz. So it's updating it 10 times a second. This is running LVGL 9, and it's made up of various parts. There's a scale around the outside that shows the ticks, the little lines. There's a second scale that shows the numbers, the labels inside that. If you saw in a previous video, we still cannot figure out how to make those label numbers move inwards slightly. So I just used a second scale that's a bit smaller. It seems to be doing the job. Then there's the arc that comes around the outside, which is the visual bit. In the final version of this, it doesn't actually look amber. It's just so you can see it underneath this light. There's the numerical representation of the same number, and then a very simple arc on the bottom that shows my fuel level and a fuel icon. And as you can see, at the moment, as it goes up, we're running at 5 frames per second at 96% CPU. So it's going very slowly visually and taking up almost everything out of our CPU. Also, this number is supposed to be going from 0 through to 160, one at a time. You notice if you look at this one, it's not actually capturing every single number. We've got some that are being missed. And it's because it's not able to actually refresh anywhere near quick enough to show every single value that's coming in. Now, obviously, if you have different kind of chips and different kinds of boards, the memory and the CPU and all that you have available is going to vary. Now, we're doing this on an ESP32S3. So if you're using one of them, chances are it's going to be somewhere in the same kind of ballpark. But the numbers and the values that we talk about throughout this may be slightly subject to change depending on your individual setup. Like I said, in this video, we are using the latest live version of LVGL, so that's 9.2.2. And everything in here is just as it comes out of the box, except for the fact that we've turned on performance monitor. So that shows the little thing in the middle of the screen. And if you're going to play with this to try and get better FPS, you want to turn that performance monitor on, because that will allow you to see the FPS and the CPU usage, which is the big things that we're interested in. We're going to come back to this file. We're not going to change anything in it now, but something major can be changed in here that makes a huge improvement, but we'll get to that later on. This is the INO file, the Arduino IDE file that makes up that display. Doesn't really matter what's going on in here. Most of this isn't being changed. What we are going to look at to start with is the driver setup, because at the moment, everything's just running off the internal memory. And it's not necessarily the most efficient way of doing things. So piece of advice number 1 for increasing the speed is utilizing DMA. Direct Memory Access is a special allocation in your RAM that can be directly accessed by peripherals like your SPI, your I2C, or an LCD driver without having to involve the CPU at all, which means those devices can go in and out of RAM and grab that information that they need without having to put extra load on the CPU, freeing the CPU up to do other things like increase the frames per second of your graphics driving. Utilizing it properly is going to reduce your CPU load so it isn't busy copying pixel data to the display. That's all being handled by the DMA. It allows bulk data transfers at high speed, which for the most part offers lower latency than using CPU transfers. And as you'll see when we get into double buffering, spoiler alert, it allows things to happen more simultaneously. So one thing can be concentrating on the writing of a buffer and the other one can be concentrating on the transfer of the other buffer. That'll make more sense in a minute. So if we get rid of this and we use this line instead, which is one I've already been using, all this is doing is setting that same chunk, that same block of data that we're going to be using for the buffer, and it's going to be allocating it to DMA memory instead of using it in its just regular old internal. And because these boards have got such a large amount of DMA, we can increase the size of the buffer a little bit. So in the default one, it's 1/10 of the screen. I'm going to increase this one to 1/6 of the screen. So let's just see what difference doing just that makes to that FPS. Is it going to increase it or decrease it, or what's it going to do? So remember, we had 5 frames a second pretty solidly running at 96% CPU usage. Just let my default loading animation go through, and what do we have now? 7 frames a second at 95% CPU, 7 frames a second, which doesn't seem like a big deal. What do you do? We've gone from 5 to 7 frames a second. But the reality of that is actually just by changing how we've allocated memory, we've got a 20 to 40% speed increase, which when we start to scale this up, and we're talking about much bigger frames per second numbers, which we're going to get to, does make a sizable difference. So if you're using a ESP32 like this, 100% get it using DMA memory for its buffer because it's going to scale a lot better. Whilst we're in this page, we can look at tip number 2, triple buffering. Now this is a weird one because I've got mixed results, and often it depends on the screen layout, which is something we'll get to in a minute, but sometimes I found that it makes no difference. Sometimes I found it adds another 10, 15, 20% onto the speed. And what we're doing with triple buffering is, on this next line here, allocating a second buffer. And then what this is allowing us to do is basically, at the moment, as it's working with a single buffer screen, you've got the screen which is being shown, and then LVGL is creating the next frame. And then what it's doing is it's swapping that frame in and getting rid of the existing frame. And then as it's swapping that frame in, it creates the next frame. And that does it like that, like one at a time, which means the transition time between each one should be lower, because it's not needing to use all the CPU to do all that stuff. Like I say, I get mixed results with it. I don't think it makes a huge increase for this, but we'll look at it anyway. So we're just creating this buffer 2 in exactly the same way on the DMA. And then lower down the page, when we set the buffers here, we have to change this null to use the buffer. So use buffer 2. And we'll just see what that one does. So loading in the new one. And no, it looks basically exactly the same. 7 frames per second at 95% CPU. So it hasn't made a huge difference, or any really. But again, that doesn't really matter too much now. It's all about how these lots of small changes start to add up until the big changes make a large difference. There is one more thing we could look at on this screen, but I can guarantee you it'll make things worse. And it's the render mode here. So it's a lot easier to set this in 9 than it is in 8, but you can change the render mode from partial to full. And what that will do is, instead of just finding the element of the screen that has changed and swapping that bit out in the buffer, it'll redraw the entire screen. Now, it is good if you're getting issues with banding, or like if you've got a meter line and it's moving around and you see tearing of the line. Using full render mode can solve that problem, but it will tank your FPS. This will go down to 2 or 3 if we utilize that. And if you use that, then you have to use a full size buffer like this. Not something I'm going to recommend that you do unless you absolutely need to. So let's keep things on partial for now. This is part of what I think the big issue we've been having with LVGL 8 and meters is. And when you put too many ticks on a meter, it starts to massively slow down the FPS. And it's because it thinks the entire meter, all of the ticks and all of the outside of it, needs to refresh as the needle moves. So it's using it as a whole massive area of screen which is trying to refresh instead of just moving the needle. It's just like an inefficiency in the way that it's produced. Fortunately, it seems to be something that has been moved away from with scales in LVGL 9. So now that I've successfully transferred everything over to LVGL 9, albeit having to use a few hacks and workarounds that I don't particularly like, but we've got to the end result with scales and with an arc, and the efficiency is so much better because those scale elements aren't being redrawn every time the associated indicator, whether that's an arc or a needle, moves. It's static, which is exactly what it should be. So there's a little bonus one in there. If you're using LVGL 8, take care when it comes with using meters, because they tend to get redrawn all the time and it can absolutely tank your FPS. Talking about partial screen refreshes leads me on very nicely to actually what you have on your screen, how it works for redraws, and so what I like to call active and passive component design. On this display, I would consider this to be having 2 active components. So this arc moving around the outside is active. It's constantly moving. It's constantly shifting, as is the number in the middle. That is another active component. Whereas the fuel meter at the bottom is something that's not going to change very often. And when it does, it changes in small amounts. It's just an indicator of something that's being monitored. It's a passive component. So the advice to actually help with that FPS is to try to limit your active components, your things that do a lot of changing, to as few as possible on any one screen. Like if you had, let's say, speed and RPM, you might be better off putting them on separate displays so that the way it redraws is minimized. Like, let me show you the difference when I remove the label from the middle of this screen and we just have the one active component and a second one, which is a passive component at the bottom, without having that middle bit needing to redraw. What does that do to the FPS? So without that one in the middle, might be surprised to see that it's just sat at the same value, 7 frames a second at 95% CPU. So why has changing that not had any effect? And it's because this is sat at 95% CPU because of this thing. So again, we've actually made an improvement that you can't see. And it's because something else is taking up the entirety of our CPU. So it doesn't allow LVGL the space it needs to grow. If you imagine that our entire CPU is 100%, if something's taking up 90% of it, and that thing has the highest priority, then LVGL is never going to get more than that 10% space. So what is it? And it's actually ESP now. And the way it is currently bombarding the Wi-Fi input into that ESP32 with new data 10 times a second. If we get rid of the V3 Speedo for now and bring in the gauges remote, this is the file that is just on that little ESP dev module right now. And all it's doing is it's got a task that's running 10 times a second, so every 100 milliseconds. Each time it's incrementing by 1. And then when it gets to 160, it resets back to 0. And then it just sends that number off. So you can see at the bottom here, all these numbers getting sent off. and that is slowing the CPU down in the receiver so much that nothing else is allowed to optimize itself. So FPS tip 5 is to have caution when it comes to how you're sending data to your gauges, assuming it's gauges that you're making, whatever it is, whether it's for automotive or whether it's for something completely differently. If you're bombarding it with information, then you're going to really limit how many FPS it's going to be able to show. So let's just halve the speed at which it's sending this information over. And what we'll do is, the reason I did this is we can then double the amount it increments each time. So the arc speed will move the same amount, but now it'll be sending half the data. How does that affect it? Okay, so we can see the arc stopped because this has stopped broadcasting data. And when it stops, it drops down to 4% CPU at 33 frames a second. So it's like maxes itself out at 33 FPS. Here we go. It's back on again. And there, right, 15 frames a second with only 72% CPU. So the FPS has doubled and the CPU usage has come down 20%. And that's just by halving the rate at which data is coming from ESP and now. The more I use it and the more familiar I get with it, the more I realize how resource intensive ESP now is. It is fantastic for a lot of things, but I think long term, for me, for what I'm doing with my car, something like RPM though, or speed or oil pressure, something that needs to update a lot and frequently, like many times a second, is probably going to be best wired in directly to hardware serial and not utilizing ESP now, because it is so system intensive. Now, I don't have a board here right now. They've been ordered, but I don't have them here with hardware CAN set up to show you how that will look. So what we're going to do is just simulate it. We're going to turn off the ESP now board, and then back on our display, and down at the bottom, very simply, I'm just going to allow this bit of code back in. So all this is doing is we've got a count 20 because this loop runs in 5 millisecond delays. So by putting a 20 count in means runs every 20th loop. So every 100 milliseconds, which is the same as what we were originally sending, every 100 milliseconds. And then we just do exactly the same. We increment a value by 1 and send that data to update speed. It's just doing exactly the same thing, but we're removing any reliance on ESP now. So how does that affect things? So as this loads up, we'll see we get now, new value is 33 frames per second at 12% CPU. Basically, the frames per second in default LVGL is set to 33 as the maximum. So it's now maxing itself out with frames as quick as LVGL is set up to handle them at a really, really low CPU usage. It's not finding this difficult at all. And it's at this point where the things that we've already done, switching to DMA and doing the triple buffering, are now starting to have a greater effect. Without them, we'd be looking more at FPSs in the upper 20s. But because we're utilizing all of these different things together and not maxing out our CPU with something blasting it 10 times a second, everything is able to start performing to its theoretical limit. And just to show that it's a lot better, we're going to put the label, we'll put the center label back in because I miss it. And there we go. Even with the middle one, you notice we're still getting 33 frames per second. And now we're able to see every single number. There's never one that is missed out because it's not getting too overloaded. So where do we go from here? We've hit the limit of what LVGL is capable of out of the box. With a couple of very small changes, we can start to make it even more efficient. And we need to do that in the lvconf file. Right at the top, we've got our memory allocation we're not going to need to change that. You might, if you start to use like smaller or larger buffers, and if say you were using full screen buffering, you might need to change this memory allocation because it won't have enough size in order to hold like large full screen buffers. But for what we're doing right now, it's fine. The thing we want to do is this, the display refresh period, because it's currently set to 30, and it's 30 milliseconds. And a 30 millisecond refresh period is 1 second divided by 30 milliseconds is 33. So this is what gives us 33 frames a second. So if we reduce that value down to 10, we suddenly have a maximum possible frames per second of 100, which is potentially a really big increase. Will it get anywhere near that? There's a way to find out. Animation is 90 odd. And as this goes in, what do we get up to? 80 something, 80 odd frames per second at 22% CPU. That is drastically higher than what it was. So now we can just ask ourselves, well, are we at the theoretical limit? If it's not hitting the maximum FPS, maybe we're at the theoretical limit. So we can test that by increasing the speed even further. So we increase that down to 5 milliseconds and then seeing if that actually further increases the frames per second. Because there's a theoretical limit based on how fast it can send the information out. But there's also a point of diminishing returns where you're sending information out so much faster, but you don't actually see it any quicker. It's like, are you really going to perceive much of a difference between 30 frames per second and 120 frames per second? On a cinema screen, maybe. On a gauge like that, maybe not. So where do we find the balance? We'll look at that in a sec. All right, as we see, we're still going up. And as it loads in, 160 frames per second at 25% CPU. Are we experiencing diminishing returns? And I think a good way to do that is to put a few views side by side and see what we think. We'll put these three things side by side. First one, the default, 30 milliseconds. This is how it is going to look when it's the default 33 frames a second maximum. Then there's 10 milliseconds with 100 frames per second potential maximum, and 5 milliseconds with 200 frames per second maximum. Let's just take a look at them all together. So what do you think? Do you notice a big difference between them? I think there is some, but it's very, very marginal. And with like a screen this size, you've got to ask yourself, at what point does it, have diminishing returns? You don't get the benefit from speeding it up anymore. Personally, I think the sweet spot is about 20 milliseconds. So giving ourselves a theoretical maximum of 50 FPS. Everything seems to just work quite nicely. Animations look relatively slick, but it's not using tons and tons of the system resource. I think as you start to increase from there into 60, 100 and beyond FPS, you don't notice any difference. And it's probably because if the steps in a gauge like this are moving so small. So if you're moving an arc from dead vertical to 1 degree to the side of vertical, how many frames can that theoretically be? How smooth can you make it? It's going to be what, 4, 6 frames, something like that. There's a limit of how smooth you can make it look. And so yeah, I think the sweet spot is about 20 milliseconds. So those are my 6-ish bits of advice for getting the most FPS out of LVGL 9 in particular. Utilize DMA for the buffer and get rid of that necessity for the CPU to handle all of that. Play with using both double and triple buffers, see which one suits best. I actually prefer in this setup just using a single buffer. Seems to work perfectly fine. Limit your active versus your passive components, so you're not having too many elements on too many different parts of the screen update at once, because the smaller the update areas are, the faster the partial refreshes happen. And as part of that, if you're using meters in LVGL 8, take care with them, minimize your number of ticks. It'll massively help you out. Look at ways you can remove really CPU intensive things like Wi-Fi and Bluetooth, stuff like that, that, you know, can potentially bombard and overload all of the CPU, not allowing it to have any buffer or breathing space to render things really quickly. And play with that refresh period. Reduce it to a point where you think you're getting a good return, and then don't worry about reducing it anymore. You're probably a lot better off. We started at 5 frames per second during this example, and we got it at the end up to 150. We're probably going to settle somewhere around 50, and that's a 10 times improvement. So all these small changes all come together to make a massive improvement to how the thing looks visually. Over the next week or two, I am finishing these gauges finally, and we'll look at the 3D printed elements that are going to hold these in the car in the custom display that I've made for them, and actually hook them all up to hardware CAN, and then we'll be able to see all of the fruition of the last 3 months of working on this come together as they get installed in the car finally. So I'm not ready. I kind of almost don't believe it's going to end. Fortunately, I do have the really big displays in front of me to do too. And over the next couple of weeks, we're going to look at the new ESP-32P4 chip, 4 large screens, massively more powerful than something like an S3. Is it going to be a massive game changer for creating these screens? I think it might be, but we'll see that in a bit more detail in the next couple of weeks. As always, if you have any questions about this kind of stuff, feel free to stick them in the comments and I'll try and get to them whenever I can. Or if you want to like chat directly or talk about your projects or get more updates about these ongoing projects, you can join my Discord. Like I say, the link is in the description. We've got a few hundred people now there fantastically actively sharing all their ongoing projects, and it's just great to see so many people collaborating on what they're doing together. Anyway, that's it for this one. I hope it's helped if you've been struggling to get the most out of LVGL, and hopefully these tips will help you get more out of it. Whatever you do with the rest of your day, folks, have a wicked one, and I'll see you in the next video. Same time, Wednesday, 2 p.m. Take it easy, peeps. Bye-bye.